Topic 8.6, Biodiversity. To help you study, I've put together a checklist that tells you exactly what you need to study in AP Bio Unit 8, and in fact, all of AP Biology. To download it, go to apbiosuccess.com/checklist. What is biodiversity? What are its components? Biodiversity is the variety and variability of life within an area, and it has several components. That includes ecosystem diversity. So if you think about an ecosystem like the one in Yellowstone National Park, there are mountains, there are meadows, there are aquatic ecosystems, so a variety of ecosystems in one area. You can also talk about species diversity, the number of different species within an ecosystem, or you can talk about genetic diversity, so if you're looking at that species, how much genetic variability is there among the individuals that comprise that species. An important idea related to biodiversity in AP Bio is that biodiversity increases resilience. What's resilience? It's the ability of a system to respond to change and to bounce back from difficulties. Here's an example. Here's a field of corn with one species, and in fact, in today's world, this might be a genetically engineered field of corn where there's really only one individual that's cloned over and over again. So we have low genetic diversity and low species diversity combined into one. If there were some kind of fungal pathogen that were to enter the system, or an insect herbivore that were to figure out how to eat this corn in the face of pesticides and herbicides and all the other things that we do to protect fields of corn, well, this field would be extremely susceptible to damage. In a grassland like this with many different species, if there were a fungal pathogen that impacted one species, there are many other species that are in this same system. Am I saying that we shouldn't be converting grasslands into fields of corn? No, of course we need corn for food and for other products, but as we develop our planet, we need to do that with an eye towards maintaining biodiversity, ecosystem, species, and genetic at as high a level as possible, because that promotes resilience. We just made a connection between biodiversity and ecosystem resilience. That's a benefit of biodiversity, but there are several more. One is that biodiversity is intrinsically beneficial. That means it's a good thing in and of itself. And to prove that, just go out into nature and you can experience the joy of the diversity of different ecosystems, the diversity of all the different species within those ecosystems, and the variability of the organisms within the ecosystem. So that is the intrinsic benefit of biodiversity. In addition, biodiversity provides many present and potential benefits to humanity. One example is the Pacific yew, which is a shrub that lives in the forest, and what was discovered years ago is that the yew contains a compound that has anti-cancer properties, and that's been developed into an important anti-cancer drug that's treating millions of people. Who knows what other compounds like that exist within the incredible biodiversity that exists in the rainforests or in coral reefs, so on and so forth. So we need to maintain biodiversity to gain those benefits. If all those species become extinct, those direct benefits won't be things that we'll be able to get. And finally, there are ecosystem services. Those are things that biodiversity provides to us for free that might otherwise have huge economic costs. The oxygen in the atmosphere, where's that from? It's from photosynthesis, provided for free by the producers of planet Earth. The oceans, when they're intact and healthy, can absorb carbon dioxide. That can mitigate climate change. That is an important ecosystem service. The bats that fly around eating insects, that keeps insects under control, another ecosystem service, and there are thousands just like that. The economic benefit of ecosystems that are intact and healthy is incalculable, and that's the benefit of biodiversity. Your success in AP Biology starts here. Are you struggling with AP Bio? With Learn-Biology.com, students get the skills and confidence to be a top student and earn 4s and 5s on the AP Bio exam, guaranteed. Go to Learn-Biology.com to find out how you can master your biology course and crush the AP Bio exam. Within the AP Bio curriculum, diversity comes up in 2 places. In Unit 7, we looked a lot at the importance of variability within species, and if you want to review that, you can go back to my Unit 7 video. In Unit 8, what we focus on is mostly species diversity. Here are 3 communities, Community A, Community B, and Community C, and what we're going to do is we're going to compare their diversity. And we're going to do that based on 2 components. The first is species richness, the number of species in an area. And the second is species evenness, how evenly distributed the members of a species are. So what we're going to do is we're going to rank these 3 plant communities from most diverse to least diverse, and to do that, we're going to do some counting and analysis. If you look at Community A, it has 3 species, 1, 2, and 3. And in terms of the number of individuals in each one, they're very evenly distributed. There are 4 individuals of species 1, 4 of species 2, and 4 of species 3. Community B has 4 species, 1, 2, 3, and 4, and they're evenly distributed. There are 3 individuals of each species. In Community C, there are also 4 species, but they're not evenly distributed. There are 9 individuals of species 1, and there's 1 individual each of species 2, 3, and 4. As we'll see in a moment, we're ultimately going to use some math to determine which of these communities is the most diverse, but we're going to start a little bit more intuitively. Community B is the most diverse. Why? Because it's tied with Community C for the highest species richness. Both communities have 4 species, and it's tied with A for highest species evenness. In both A and B, the species are completely evenly distributed. But how would we compare Community A, 3 species evenly distributed, with Community C that has 4 species, but they're not evenly distributed? To properly compare the diversity of different communities, we're going to need to use a formula. That formula is the Simpson Diversity Index. Let me tell you what it is, what all the symbols represent, and then we'll use it to figure out the diversity of Community A. Little n represents the total number of individuals of each species. Big N represents the total number of individuals of the entire community, and this symbol means the sum of. So here's the diversity index. Let's compute it. So for species 1, there are 4 individuals. 1, 2, 3, 4. So we're going to plug 4 in over here. Then we have to figure out N, the total number of individuals in the entire community, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the total number of individuals in the entire community. So small n divided by big N for species 1 is 0.33. 4 divided by 12 is 0.33. Then we take that value and we square it. 0.33 squared is 0.111. For this community, it happens to be the same for all 3 species. So species 2 also has 4 individuals out of a total 12 in the entire community. So the values are the same. Again, n over n squared is 0.111, and that's true for species 3 as well. You add those all together, and that comes to 0.333. You subtract that from 1 minus 0.333, and the value is 0.67. That's your diversity index for Community A. I'm Mr. W from Learn-Biology.com, where we believe that interaction and feedback is what leads to deep, substantial learning. We're so sure of that we provide a money-back guarantee that comes with your subscription. Let's repeat the same steps for communities B and C. For community B, there are 4 species, and let's count how many members there are of species 1. There's 1, 2, 3. So small n equals 3. The total number of individuals, again, is 12. 3 divided by 12 is 0.25. The values are the same for species 2, 3, and 4. There are 3 individuals for each of those species out of a total number of 12 individuals in the community. So 0.25 is n, small n, divided by large n, and then we're going to square it. 0.25 squared is 0.063. The value is the same for each species in this community. We add that up, 0.063 plus 0.063, etc. We add that up, and what we get as our sum is 0.250. 1 minus 0.250 is 0.75. So we see that the diversity of community B is indeed higher than that of community A, and that's because the species richness is higher, even though the evenness of both is the same. They're completely even. Our question was about comparing the diversity of community C with community A. So let's run the numbers for community C. Like the other 2 communities, it has a total of 12 individuals, of which 9 belong to species 1. So we're going to do little n divided by big n divided by 12. We get 0.75. Then we're going to square that, and we get 0.563. So that's what this value is for species 1. Now let's do the same for species 2, 3, and 4, because it's the same number for each of them. There's 1 individual. 1 divided by 12 is 0.08. That's little n divided by big N. We square that, and we get 0.007, and that's the same for species 3 and 4. So we're going to add up all those values because of this expression over here, and when we do that, we get 0.583. We know that we have to subtract the sum from 1, so 1 minus 0.583 is 0.42. So we see that community C, even though it has 4 species, has a lower diversity than community A, and that's because it had very low species evenness. So we can see how by analyzing each of these communities using the Simpson Diversity Index that community B has the highest diversity, 0.75. And again, think about why that is. It has high species richness and high species evenness. The next community in terms of diversity is community A, which also had high evenness, but its richness was a little bit below that of community B. And community C, even though it had a higher species richness than community A, its evenness was so low that its diversity index wound up being lower than community A. That's how you use the Simpson Diversity Index to determine the diversity of various communities. Here are your next moves for AP Bio Success. Please subscribe to learn-biology.com and please watch this next video.